Good afternoon, everyone. Welcome to this session. I'm here to talk to you about how United Airlines is working towards modernizing its flight operations technology. But before I go into the details, I wanted to kind of show you the small video and bring to your attention what we are calling it as the new spirit of United. What that means is everything that United management is working towards is we want to make sure that anything we do, we are working hard to not only earn the trust of our customers, but our employees as well. Any project we undertake, any initiative that we take, we are making sure that it is towards a purpose of serving our employees as well as our customers. A little bit about United. United serves over 4,500 flights on a daily basis across 6 continents. It has its partner airline in United Express, where we serve even the small cities throughout the US. Last year alone, we transported over 140 million passengers all across the world. United itself owns a fleet of more than 700 aircrafts, combination of Boeing and Airbus that it owns and manages. We have a strength of over 87,000 employees in every country of the world. Out of this 87,000 employees, we have a group of mobile workforce, the pilots and the flight unions that form the flight operations division, 10,000 pilots and 25,000 flight attendants. And then we also have over 6,000 employees that are working at the airports as gate agents, ramp agents, and customer service agents. I am Tejal Patel. I work in the IT department for United Airlines, and I serve the needs of the flight operations technology. When I say flight operations, I mean the pilots, the flight attendants, and any management staff that works in our corporate support center, whose primary job is to help and support our crew when they are out in the field during operations. So talking about some of the things that we have done lately for our pilots and flight attendants. First, I want to talk about our pilots. What we've done in the last year for our more than 10,000 pilots is we've issued each and every pilot an iPad device. So I'm not sure if you've noticed at the airports, pilots walking around, they used to carry a huge manual book. It weighs about 45 pounds that contained everything about the aircraft they were going to fly, any emergency procedures, policies, anything that they would need to know during the operation of that flight. And if they needed to look up that information, they had to go find out what page it is and then look up that information, look up the map. Anything that they needed for operating the flight from point A to point B was given to them on paper, what we call as the flight pen. It guides the pilots on how they're going to fly their aircraft. We've taken all of that information and in working very closely with the FAA to get it certified, we've transferred all of that information onto their iPad device. So today, everything is available to them on their iPads by just clicking the search button. They can look up maps, they can look up flight information, any procedures, processes that they need to, as well as their own information about what they are doing in terms of operations. Where are they flying next? What hotel they're going to stay at? And it also helps them identify the in-flight crew that they're going to be working with. So all the information that they would need, we have provided them an iPad device. The reason for this is that it enables them to focus on the operations of the flights, and we work hard to make sure that this information is provided to them in real time, is accurate, and is reliable. Because nothing is more important to United than safety of our passengers and our crew members. So similarly, as we issued iPads to our pilots, what we've also done is we've issued iPhone 6 Plus to over 25,000 flight attendants. Today, you would see these devices in the hands of flight attendants or during the flight when they are either serving snacks to the employees or they're trying to report any malfunction, any seat broken, or any kind of issues that they see on the airplane. This device in their hand gives them a lot of information to make sure that they are serving the customers in the right way. One of our focus has been, as we develop these applications, is not to just develop applications for the sake of it, but to make sure that anything that we build within the applications is for a purpose. It's for the purpose of serving not only the customers, but also to ease the way these flight attendants, the way these pilots manage the operations. And I talked about I serve the needs of the pilots, flight attendants, and what we have as the management staff back in the corporate support center, right? So while we have issued these new devices to pilots and flight attendants, our support staff in the office still uses this. How many of you can recognize this screen? Does anybody know what this is? Okay, less than 10 hands. I'm sorry? Yeah, this is our crew management system, our mainframe-based system. So what happens is when our pilots and flight attendants are out in the field, we have a staff of over 150 to 175, what we call as the schedulers, who sit in the Willis Tower on the 27th floor and provides every information that they would need, any support they would need, any issue that these guys have out in the field, they'll pick up the phone, call the schedulers, and get it resolved. So this is a system that our schedulers use today. I've tried this. You have to know what you're looking for. There are 5-letter commands, cryptic commands like CMCCOD or CMPOS. You have to know what that means. You have to know what the information that command is going to bring to you. So when you are in a sensitive operational situation where every minute counts because you're running against the clock, it could result in a massive flight delay or even a cancellation. This becomes very cumbersome, and it's extremely stressful for a crew scheduling team who's trying to solve the problems for the crew. We often talk about the disruption that any irregularity in our operation causes to our passengers. And when I say irregularity, even a 15-minute delay or a 2-minute delay from operations perspective is an irregularity because it's not planned for. That is not what our schedule has it, right? So we have a lot of tools out there that provides support, that provides information to our passengers. But we often don't realize that the same irregularity that's affecting the passengers is also affecting our flight attendants and our pilots. A flight cancellation, a long flight delay. It kind of disrupts the plan that we had for them. So just like you have a trip when you're flying from A to B, B to C, we also have something like that for the pilots and flight attendants. That whole itinerary gets disrupted. For example, the crew is scheduled to fly from O'Hare to Denver, Denver to SFO. Snowstorm hits, O'Hare, Denver flight is canceled. Now we're left with a flight from Denver to SFO that probably won't have any crew. We are left with a crew out in Chicago who reported for duty, who have nothing to do. And we have to figure out what is going to happen to that schedule. So this is where the crew scheduling team jumps in. Their job is to make sure that not only do they look for any such irregularities through the operations, but also make sure they try to get that recovered as soon as possible. When this team of people work in the NOC, believe me, the last option that they consider is canceling a flight. They'll try every possible option that they can to get a different crew, to get a different plane, to try any possible option that they can before a determination is made that, okay, we want to cancel this flight. So it's very important for us to make sure that we give them the tools that they can walk through, especially when we have major snowstorm that we had last year in the East Coast for 2 days, and we ended up canceling all the flights in and out. Planes have been grounded, crew is stuck, and now when the snowstorm is over, that's when the actual work begins. Because now we have to recover our operation. We have to try and get everything back on schedule, the planes, the crews, the flights, the passengers, everything. So as we looked and tried to study of how that is done today in the life of a crew scheduler, this is what we uncovered. So let's say in the scenario that I gave you, the Denver SFO flight, we call it as an uncovered flight because I don't know who my pilot is going to be. I don't know who my flight attendant is going to be. So crew scheduling team jumps into it, try to see what I can find, who I can find to carry on with that flight. Now they're going through that crew management system that I just showed you, trying to figure out available crew, who has to be legal as well. Because Ravi talked about the FARs that we have, the Federal Aviation Rules. Those are very strict in the US, and every assignment that we make has to abide by them and not violate them. So they jump through different systems trying to figure out what that information is, who that crew member is going to be, how they're going to make this flight happen. Sometimes it's a simple solution of just picking somebody from here and putting there. Sometimes it's a complex swap between get a pilot from here, flight attendant from here, get from here, and try to do a multiple swap that they have to do. And it's, like I said, they're running against the clock. So last year when we started studying the crew schedulers and what they do for day-to-day work, right? We came up with, we initiated a program and we're calling it the Crew Modernization Program, wherein not only we want to look at the tools and technology that will help us replace the green screen systems that I just showed you, but also help us in development of systems that work along with the life of a scheduler, work in the way that a crew works, and gives them processes that are easy and efficient and makes them in turn efficient to do their daily job. So we set a very simple objective when we started our crew modernization program. What we want to do is we want to build a foundational system. It has to be a foundation system to serve the needs of every channel that we can think of from crew perspective, whether it's an iPad channel for pilots, an iPhone channel for flight attendants, our crew scheduling applications, a web portal, or anything that we have from crew perspective, we should be able to serve the needs of those channels. And so we went and talked to the users to say, okay, as we design the system, what are your priorities? What do you want? For them, nothing topped their priority list than delivering accurate real-time data, because nothing is more important in them than anything. They don't care about the looks of the system. They don't care about the color palette. All they care about is making sure that they have real-time accurate data for flight operations. And then, of course, by way of that, if we can make the tool simple and streamline it to improve their life, they will be very happy. So as we dig into the systems, and that's when we got introduced to the crew management system and the green screen systems and the commands, we realized it's not an easy problem to solve. One of the things that I want to mention to you is, as you know, our pilots and flight attendants, they are unionized. What we have in place today in the US is we have a set of rules that we have to follow called the Federal Aviation Administration rules, the FARs, plus we have these contract rules. All of these rules are called the business rules. Every scheduling assignment we make, every reassignment we make in case there is a flight delay, cancellation, or any other thing, those rules have to be followed. We cannot find a solution that may even break one of those rules. If it is, that's not a solution to consider. We definitely cannot go for it. And today, all of those rules are embedded within that system that I showed you, which is a COBOL-based system. Any change, the union contract changes every 3 years. The FARs, new rules come in at any point in time, and all the airlines have to implement them within the given time frame. Making any sort of change into this COBOL-based system is complex. And if that was complex, testing that is even more complex, because all of this is flat file system, right? You have no idea how this code is entangled with each other's screens and how it impacts the entire system. And as time passes and we move on to new technology, we have less and less number of experts that are out there who understand the systems, who know how to make changes to the systems. So what has happened over time is, because of the complexity of the systems that we've built, a lot of the emphasis that we put for our operational purposes is on the end users. Some of our schedulers are highly skilled. They have years and years of experience. They can solve a problem in a matter of seconds, even before I can even blink my eye. But then, as new workforce comes in, they are pretty new to the systems. They have a tough time trying to remember the commands of the system, trying to figure out how they're going to solve the problem. And then, of course, we wanted to make sure that we tailor the tools to the way the crew scheduling workforce works, how they operate a system, how they find a solution, how they need the information organized and collected from multiple different resources from all over the systems within United. And if life wasn't just simple that way, we said, okay, as an IT division, what do we want to do? So we said, okay, we just don't want to build another web application, because we have that. We have applications that today are built and then interact with mainframe through through various services, where you end up doing a lot of transformation back and forth in the way the system understands, the way web application system, and any change you have to make is complex. So we were very sure that we did not want to repeat that. We wanted to make sure that we build a stack that allows us to be flexible in implementing some of these requirements. And the rules that we talked about, we had to get those rules out of COBOL-based system. We had to put it out in the system that we can manage, that's easy for us to change. So no matter when a new FAR is introduced, no matter when a new contract is signed, we can go in and quickly turn around those changes, right? And of course, we talked about pilots having their devices, flight attendants having devices, crew scheduler will have their own applications, but they all interact with each other on a daily basis. So when a pilot or a flight attendant calls us to say, hey, I want to call in sick, I have so many days of vacation left, I'm looking at my calendar, or something like that, we want to make sure that the crew scheduler from the back office is looking at the same information that the pilot or the flight attendant is referring to. They cannot be talking about something that's totally different because their device has this versus their application shows that. So we had to enable a single source of truth for all of this, of pilots, flight attendants, and schedulers. And of course, performance, high availability, disaster recovery, all of that just goes hand in hand. Today, any system you build in, especially for an airline, which is highly operational 24/7, any given point in time, we have a plane that's out there flying. We have to make sure that these are the systems that we can rely on, they are highly available, and they perform to our needs. And then the last, but very important, was we have a mobile workforce that we support. 35,000 crew members that are on the road all the time managing our operations who carry a mobile device. So anything that would aid us in doing a mobile application development would be a huge, huge benefit that would help us in the future. This slide kind of gives you the stack that we have designed for our first phase of our system. So if you go from bottom up, we have our mainframe-based system, the crew management system that I showed you. And then, of course, we have other systems also that give us flight information, that gives us aircraft information, that gives us maintenance information, and any other information that we kind of need to collate with the crew management system and put it in the context that our end users would need, whether it's the schedulers or whether it's the crew. So different messaging types, we get that information within our crew foundation platform. Our crew management system gives us in the form of IBM MQ message types. Other system gives us, we use TIBCO EMS. So all of these different formats make way into our crew management system and our crew foundation system. That message gets passed, broken out, and stored into our Couchbase layer. So Couchbase is our choice for NoSQL database for making sure that we have all the information collected, stored, and highly available to any channel tomorrow that we build or we may migrate into our crew foundation, and that we were building for our schedulers today. And around our Couchbase layer, what we've done is we have put in our other components that we need to be using IBM ODM for our business rules management. For every rule that we have in terms of the contract and FARs, we're going to be implementing using the IBM ODM. And then we have TIBCO as our complex event processor that kind of ties everything together, that interacts with ODM, gets the data from Couchbase, gets the results set back from the rules engine, puts it back in the Couchbase, and makes it available to the end system. And then we use Sync Gateway as an API for connecting to our web applications and our mobile apps. And web applications, that's the first one that we are in beta right now, where we have implemented a solution for our crew schedulers. So this is just a mock-up of what that system looks like. So today, when the crew schedulers learn about any irregularity, they have to go look up information. Tomorrow, with this tool available, what happens is we are able to collect the information from various sources, run it through our rules engine, interpret it in the way that the crew schedulers would want to look, and bring to them what is happening around the entire network. It could be a Hong Kong Newark flight, or it could be a domestic flight that's having an issue. Any other issues that are happening around the system, the schedulers will be able to see that in one source collated together. And just by a few clicks here and there, they're able to figure out what this flight is, which aircraft that flight was supposed to be on, who are the crew members assigned to the flight, what does this crew member's calendar looks like. If I delay a flight for certain reasons, am I going to violate the crew legality? I cannot have a crew break any of those rules. All of that information is available to them today with a few clicks here and there, and they're able to navigate that information, look up other information, and make sound decisions for managing our operations better. So that brings us to the questions: is why Couchbase for United? So last year, when we started the exercise, we looked at a number of tools that are out there. We looked at the solution, we looked at our stack, We looked at RTBMS, and there were a couple of reasons that kind of steered us into way of Couchbase. We did our study, of course, and in our checklist, there were certain things that kind of just put Couchbase above everybody else, right? First and foremost, the mobile enablement. I mean, we've done POCs to help us understand how that would work, and it's just seamless. Having a Couchbase system update work through Sync Gateway and Couch Lite to update the end user device with the latest and the greatest information as soon as the user logs in, it's seamless, right? Highly available. We have 2 data centers today that support our operations. We have nodes that are node clusters that are deployed in both the data centers that replicate data using XDCR bidirectionally, which makes sure that at any point in time, no matter anything happens to a node or two, the systems are still up and running. There is no downtime that we have to go through. Resilience. I'm not sure. I mean, when did you last see an airline have a problem with their IT systems, right? They're always up and running. So this was, I mean, it was funny that some of the incidents happened when we were going through this design, but this became a very important criteria to make sure that we have a built-in DR capability that enables to. It just isn't sufficient to say, okay, hey, I'm going to have my web applications deployed in 2 data centers so the users can go anywhere. But I also need to make sure that I'm able to serve the needs of those web applications, have the data available to them. So having the out-of-the-box XDCR just configured, set up by a few clicks, and make that available, it has been working out very well. We've been testing it thoroughly before we deploy it out for operational reasons. We have to make sure that it works the way it's intended to. No matter which data center you connect to, the data is there, it's identical, and it's in real time. And it's good to know. We haven't started experimenting, but it's good to know that we do have cloud support available to us as well, if in future, if things steer that way. So what are some of the observations and learning? I think I'm not sure about how many of you, but for us, it was a big learning is adapting to the NoSQL and just unlearning SQL, right? Because the first time you give it to a developer and you talk about this, he'll start doing it the SQL way, try to organize the data model schema in a SQL way and rationalize everything. So it did take us a while to get over that and realize the benefits of having that data in the format that the NoSQL supports and how it can benefit our downline applications, serve multiple user needs by supporting multiple formats and multiple schema. As we tested our response times, and we are still going through that and fine-tuning, it becomes very important. I mean, we realize that the best way to get the max performance out of Couchbase is to maximize your key value access. That is the way to go. Your response times are in milliseconds, sub-milliseconds, and it just works great if you design your data model in a way that you can take benefit of that. We always have traditionally relied on business keys to access our information, search for our information. So we made sure that we try to clean up in a way that we are able to go to key value access to get better performance out of Couchbase. 2 weeks ago, we upgraded to 4.5.1. We had started our initial development with 4.1. And we are in, like I said, we are in beta right now. So we are in sort of a production mode where the users are actually testing the system thoroughly and making sure that it's functioning the way it's supposed to. So we were a little concerned about how we are going to go about doing this upgrade during the testing phase where the users are live and looking at the system. But there was no downtime. We were able to take nodes out one by one, upgrade it, and put it back in the system, rebalance the data, and have it up and running in no time. Our users didn't even know that we were doing that activity. And I think from our administration perspective also, it was very, very easy for us to do that upgrade and make sure that there was no downtime at the end of the day. And the last is the multidimensional scaling. So Ravi talked a little bit about how you can configure to have your data nodes, your query nodes, your index nodes, or combine them as per the needs of a thing. We're still playing around with this. We're trying to figure out still what will be that best combination that works for us. We are using a lot of NQL queries in our application. We are trying to get into the memory optimized indexes and working through that, fine-tuning that to make sure that it works the way that we expect it to. So So there are some other spaces within United that we are trying to take advantage of Couchbase. And just to highlight a few, the first one that Ravi talked about is how can we take the customer information. You have your boarding passes, you have your mileage plus information, you have your reservation details, you have your flight details. How can we collect all of that, put it together, and make sure that we sync it back with the United server? So no matter what, whether you're online, offline, you have all of that information available to you, and it's all synchronized with our United systems. The next one is the airport agent UI. So just like our mobile workforce of pilots and flight attendants, I mentioned we have over 6,000 agents that are walking around in the airports, gate agents, customer service agents. We have equipped them with iPhone 6 Plus as well. So the idea is to make sure that we also provide them with the same information they would need to serve a customer. On busy weekends like Thanksgiving, Christmas, you see people walking around trying to serve the customers and answer the questions. Having a device in their hand, trying to make sure that they can pull up the information about a customer if they have a question, that would be great. So that's one of the other areas where we are experimenting with how we can provide the same information. At the end of the day, it's about your flight, it's about the times, it's about your reservation. All of that information present to this agents as well, so they don't have to be locked behind a system and standing behind the desk trying to help the customers. And last is the gate displays. This is the big monitors that you have noticed that are at a given gate, right? It kind of shows you information about the flights that are coming in at the gate or the next flight that's departing. It gives you weather information and some advertisement content. So there's another system that we are looking at to see how we can make sure we sync it back with our United systems in the back end, provide real-time updates. So we have various channels by which users can have access to information, whether it's flight, reservations, and all of it. So idea is to kind of bring all of this together and make it sure that they're all synchronized. It's all real-time updated. And most of all, we want to make sure that no matter what system you look at, you're going to get the right answer. We don't want to have you look at a gate information that's different over here or a flight information that's different over here, right? So with that said, I'll answer any questions you may have. Behind you.
Okay. In here, you talk about messaging, pumping data from your mainframe and other systems into NoSQL. Mm-hmm. And you talked about 2 clusters. So do you have like an active-passive cluster, or both are active-active at the same time? Because I think choosing to pump messages into both at the same time will make both clusters immediately consistent.
Right.
And how do you manage that?
Okay. So the way we have our Couchbase clusters, the topology defined is the Couchbase clusters themselves are active-active. But the systems that resides below that takes the information from the source systems and updates Couch is set up as an active-passive. A couple of reasons for that is the information that's coming in from various systems. Let's talk about the crew management system itself. It has to be serialized, because I could have a trip that I'm going to make a change to. You could be, as a scheduler, you could be making a change to that same trip for another reason. I cannot have that split across multiple, deployments and try to update to Couch where then one of them might overlay the other one, right? So for that purpose, synchronization is very important for that. So we have made sure that the downline systems feeding and the layer that updates Couchbase from the source systems is active-passive. But then the Couchbase clusters themselves, so that when we look at the applications from above, the web applications or the mobile applications that will interact with Couch, for them, it's an active-active connection at all time. And then with the help of XDCR, we are able to keep that data in sync, even though the update is happening only in one data center.
So you talked about the messaging system coming from the old mainframe pieces, but how many other data pipelines are there feeding Couch and then the Couch feeds to keep all of this stuff going? I have this picture of lots of different data streams from lots of different sources doing that. And is that all on MQ series and TIBCO? Are there other systems you're using for keeping those data pipelines happy?
Yeah. So the data that's coming from the mainframe system is IBM MQ, but when we have other systems where, for example, the system that's feeding us the flight updates, that comes in the form of TIBCO EMS, what you call the enterprise messaging, which is an XML-based format. So though there are different formats that are coming in. And we also do have nightly updates that come to us in form of flat files for crew updates and things like that, that again is fed through. So we do have various different formats that we subscribe to and are using to update our Couchbase.
How do you input data into Couchbase? The recommendation is to always go through Sync Gateway. Is that what you're doing to put the data into Couchbase server?
We're doing it both ways. We do it through Sync Gateway as well, plus we have a direct. So our backend systems that updates Couchbase when they receive messages from the source system, it's a direct write into the Couchbase. And then the other applications that are subscribed to that same information is via Sync Gateway. Any more questions? Well, if no more questions, then I would like to take a moment and thank the Couchbase team, many of whom are over here, for their support. They have been very, very helpful in United's journey, migrating from something like that COBOL-based system into the world of NoSQL Couchbase. So I appreciate it. Thank you so much. And thank you, everyone, for your time.